So, time for the electrical assembly. It says to put a heating band around this coupling. So, electrical bag, the heating band is this one. I think these are meant to go through the hole on the bottom where we put the grommets in earlier. So I will just put the heating band on the bottom. I mean the cables of the heating band. Oh, apparently. So there's a hex nut here. So time to get an Allen key. It is indeed not metric. So, seems that it would have been easier to put this on without the nozzle in place, but who am I to judge the wisdom of the people who made the instructions? I'm just gonna undo the screw a bit more, see if it will go through. So in the picture it seems like this band is pretty much at the end of the coupling, so I will do the same and tightening. I mean, not that it moves much as is, but I guess there's a reason to tighten. Okay, one band. So the standoffs should just go inside here in the holes on the board and be caught on with one of the tiny nuts provided in the bag. Just like so. When working with parts so small, I wouldn't recommend doing what I'm doing and working over the floor, because if I drop it, it's just gonna go who knows where. So you may want to actually be working over a table, but I'm just doing this for clarity. So this is the installed standoff and nut, and we have to get one in each corner. So I'll just do that off camera. After a bit of double checking, I actually noticed that these standoffs should be facing towards you as you're looking at it, because the board is going to be installed on this like laser cut L thing, like so, right? So the standoffs have to be facing you to screw it in. So I'll just go fix that now. Okay, now the standoffs are all installed in the correct position. I also added the heatsink because it came included, so hey, why not? So these are the laser cut parts, and to peel them off, it's a bit finicky, but if you can just get your nail in here, you can take off the protective sheet, and the finish is very nice on them. Make your Filastruder look very nice. Okay. Cool. Now, I think these tiny screws are the ones that are meant to hold the board on. And again, we have to get our US Allen wrenches. This project would be a complete pain if you only have metric stuff. Wait, I did this stupid again, didn't I? Should always check. Should always check the reference picture. I had it upside down. So, before causing damage, let's undo this and turn the board around and now put it in the right way. I don't think these go very deep, but seems on there. Right, pull, seems fine. All of this should just get stuck here on the back in these two holes. Let's see what screw we need. So, the bigger ones. Okay, seems to be on there. Hooray! And it actually looks like the photograph. So we have to put in the PID controller, which is this one. Comes in its own little box with this piece of plastic. This is designed to actually hold it in. So it'll go in the hole here, and this piece of plastic will go on the other side, and these little fins here will catch onto it and secure it in place. Let's take off the paper. I don't know if this paper should come off. I kind of like the look of it. I think I'm just gonna leave it like this. Okay, and on this side. So it's easy to tell which piece you need because the other one doesn't have a hole. Alright. This should be the outside, I think. So this goes in. And on the back side, we just shove this through. Right. Nice and secure. One temperature controller installed. So, after some time, I have the stall protection board installed, and it says in the instructions, now is the time to test it. So you will see here these two screws. They are marked slightly differently on the board from what the instructions say, but they're in the same position. So you have to zero both of them, which means basically rotating each screw counterclockwise till it clicks. The click is quite audible, so just keep going till you hear it. It says you might need to do dozens of turns, but For this one, I probably turned it for like, I don't know, 10 minutes. And this one, it was like half an hour to an hour of just turning. So it was probably hundreds, if not more turns. But yeah, if you're doing this, don't give up. Just keep keep doing what you're doing until it audibly clicks. You should hear a click each time you turn it counterclockwise. It's just like a slip mechanism preventing further rotation. Then you have to rotate them clockwise to set the parameters. So this one goes 15 rotations clockwise, and this one is about 7. And once you've done that, they say to put the input power and connect the output to the heater. But first, just to make sure we don't fry it, we have to measure the polarity of the power supply. Turns out, actually, that, let's see if this is visible, it's kind of black, so it might not be the best. Okay, so input, it says 100 volts to 240 volts. So I'm in Europe, and I tested it, seems to be fine, puts out 12 volts, so this is good. At the other end, you have your standard connector, and they supplied us in the electronics bag with its mate that will connect to the device. So, like so. It has some leads. Now they say to check the polarity before putting it in, so I will do just that. Okay, to make my job a bit easier, I've taped the cable with a bit of duct tape to the table. Here is our multimeter set to 20 volts, and let's power it on and see the polarity. We should get something like 12 volts, so it seems that this one is the positive. Okay, power it off. Now I'm just going to take a little bit of duct tape of the red color, and I'll put it around the positive lead to mark it. Okay, so black for negative and red for positive, and we are golden. Okay, so it's time to test the stall board. So it says connect the power supply directly to the board at first. Let's just see. So up is positive, down is negative, so this should be fine. Screwdriver. Okay, they seem to be both in. Just gonna put the power supply on the table so we don't force the leads. Now, for the heater, it really shouldn't matter much how we connect it. It's just the resistance. So this is the output terminal. I took some of the insulation off the wire. I highly recommend you buy one of these things for doing such stuff. It's really great for cutting wires and for stripping wires. Here you have some holes, just put the wire in the hole, clamp it down, pull, and you get a nice clean wire. Don't know what it's called in English. Sorry about that. Wire stripper, maybe? Maybe it's a wire stripper. Sounds like an adequate name. Okay, seems in there. Let me just place this in a manner that I won't burn anything on the desk, and let's see if it runs. Since I don't have an emergency power off button, I have this. Maybe it's not the best idea to hold it in my hand while doing this, but hey. Check the input again. Top is positive, so should be good. Hey, it's on. Okay, let's see what the instructions say. Tapping the out button will cycle through the following measurements. 1.8 amps. Six volts for the output, 1.5 to 1. Okay, 12 volts, about 8 volts out. .8 amps, so we're maybe a bit higher than what they recommend, but only by a bit. They say 1.5 to 1.7 amps, so the power supply can give us 8, so I think we're good. Like 10% difference. I'm not gonna try to modify the settings. Okay, so the board seems to be working, so we can continue with the rest of the assembly. So, quick update. I had to cut off the wings that the holder for the PID had, this white part. I used the Dremel. You can see some of the damage here. I also put in the buttons in the front. These do not stick in very well. Okay. So they come out quite easily, I think, because the plastic is too thick. They're designed for thinner sheets. See, something like that. Length probably. Thickness, sorry. Something of that thickness. And I connected up one wire to the power plug so far. So the next step, it says to go from the outer pin of the mains connector, the main switch, to the outer pin of the other switch, which is labeled motor, and to pin 9. This is pin 9 for my PID controller, and to pin 9 of the PID controller. All the pins on the PID controller seem to be marked, so you should check before actually connecting it, if it's the right pin. To do this, since this should be the negative, I am going to cut some of the black wire to length, and then I'm going to solder it together to make the joint. Okay, so we need a length of wire, let's say about this long. Right. Okay, that's one. And I'm going to run the wire on the bottom because on the top there's the extrusion shaft, so I don't want it to rub against the extrusion shaft. I think it might be a better plan to run it along the bottom of the PID controller and the device. So let's see how long this wire needs to be. maybe leave it a bit longer than it has to be, just to have some give. And if we need more wire, we can just get some wire from the electronics store. Okay. Now let's strip it. If we strip it too much, we can always add a bit of electrical tape or some heat shrink tubing to it to cover up and insulate. So there we go. Perfectly stripped wire. Seriously, buy one of these. Okay, let's get some wire connectors of the blue kind. There we go, second one. So the first wire can just go in, I think, but I'll leave this to the end. First, we should connect these two wires up and put them into one of these. Give them a nice twist. Now we have to solder the two pieces together. Just put my solder somewhere I can reach it. A bit of flux and that was the completely wrong end. Alright, this should be nicely soldered, I hope. Also, I've looked closely and it seems that these wires are not one single piece, so the strands come out. I will actually add a bit of solder to each part, just to make the wires nice. Okay. Now let's see if we can get the connector on. And because I'm a bit paranoid, just gonna check that the wire is sufficiently in. Okay. Cool. So that's good. Now to clamp this one down. Okay, seems in there. So the other one I will place in the same manner so they are aligned. So I'm just aligning them in space so that the fit is nice. Should be good. Quick recheck. Yep, we can just put this in. That's one. That's two. This one should go to pin 9. So to put it in, just undo the screw. Seems in there. Okay. Looking at the circuit diagram, it seems that the two fans, the one for the motor and the one for the uh, for cooling the filament. Together with the input, the positive input of the stall board protection, go to the positive of the motor switch. So I'm just going to wire all these three up in one cable and put them in their respective places. Of course, for that we will need some red wire to go to the stall board. After a bit of finagling, I figured out that I should wire the short fan, the fan with the short lead, directly into the stall protection board, and then have another wire coming through the grommet to the switch, where it will meet the other fan with the longer cable. At first I thought I'd connect them all to the switch, but this lead is much too short. So let's just measure out a length of red wire. So it should be able to come from here through the grommet. Let's see. There. Let me just plug everything back in. Stripped all the wires, put everything back in. And now I'm just gonna join the smaller lead of the fan. I mean the fan with the smaller lead, red to red. So after some consideration, I thought that I would also extend the black lead. As it seems the fans have to go, so the negatives of the fans go to the stall protection board and the negative of the power supply. They all meet in pin 10. So I'm just going to get get these two fans in the negative of the power supply and extend the cable, and I'll meet up these three wires in pin 10. Seems reasonable, I think. We shall see how reasonable it truly is. So let's start fluxing. Okay, so that took a while, but it is done. So let's get these in. So positive is up and negative is down. So just screw them into the board. Make sure it goes all the way in. Especially if you're like me and you're bad at soldering, the screw will also keep the wires in place. So okay, that's one. I made my solder joints a bit crap, so they won't quite fit inside, which isn't great. I think the problem is that I just put way too much solder in. Okay, I think I might have gotten it in. mostly at least. Right, so this will be put somewhere around here in the end, I think. For now it can lay on the ground. And I should have made sure my wires weren't catching on each other, but this is solvable. There we go. Now it's free. And we can get these through the rubber grommet at the bottom into the case. One cable. Two cables. Okay, so exquisitely wire managed, is it not? It's like amazing. Anyway, now we have our two cables here. We can put the fan somewhere. Now we need to get the other fan cable in. So I already stripped these wires. This fan will be somewhere on this side at the very end of the extruder, so I think we can just get the cables through the grommet and that's that. I mean, if I can. Okay, finally. And I think it might be a good idea to also put the thermocouple wires in. Okay, that seems like enough thermocouple on both sides. And now let's see if I can get these wires back in. So right, back to soldering. So before I get too many wires tangled up everywhere, I'm just gonna short out pins 8 and 9 of the PID controller with a little red lead because I used up all my black wire, so I could get more, but the shop is far away and I'm a bit lazy. I undid the screws and I'm just gonna try and put in the jumper cable here. Let's see. Since nothing else comes in here, I think it might be a good option to just solder these two together. Took a while to get the wires in, but here they are. Alright. So that's sorted. Back to getting the negatives connected up. I tangled up the wire that comes from the fan with the wire that comes from the stall protection board. And just move this a little bit. I'm gonna solder them together and put them in the plug. Get that part done because that's all that seems to connect here. So it's the fan. This other fan is already connected to the stall protection board, so just get it in the plug. Time for some more expert soldering. Like and subscribe for more soldering tips. Right, connector goes in. Hey, seems to be in. And inside the board it goes. Come on. Come on. Okay, there we go. Now it's in. Only took all of the effort. Good. I think I'm gonna need a lot more wire. So now, done with the positives, time to go to the negatives. Let's see. So, what do we have here? Power supply, stall board in, negative. Fan negative is already plugged in, I think. So the black wire from the stall board, the fan and the power supply and the heater go into pin 10. Oy. Okay. We'll see. Well, after thinking about it for a little while, I think I'll get the main power and the heater wire together, and the other two wires. So I'll make two connections in the 10 pin of the PID. We'll see how this goes. Hopefully it's a good idea. If not, we can always desolder stuff. It's possible that I should have done a bit of cable management before soldering everything together, but a bit late now. So, pin 10. You should really cable manage this a bit better than I did. One cable. Okay. Now if I can finagle this second cable in, that would be glorious. Hey, it seems to have worked. Good times. So the other heater wire goes to pin 7. Okay, so the heater is connected. The thermocouple goes to pins 3 and 4. So on the other side should be these ones. Question is, do I need to take this off? Nope. Doesn't really fit. Need to know the polarity of things. So the plus is the small one. Let's just open this thing up. Get the wires out. Okay, so the wiring diagram says that pin 3 is minus and pin 4 is plus. So it should be the other way around. Just gonna do the electrical tape thing again. Stuck to my hand. Okay, so that's the positive. Minus is 3 and positive is 4. So, like so. Okay, maybe it's not the worst thing that I put a bit of duct tape on it. Should help out. Hopefully we get a good contact. If not, it will come undone and we'll redo it. So let's see. The heater has been connected, the thermocouple has been connected, the power supply has been connected, the motor has not been connected. So the motor goes to the protection board, just plus to plus, minus to minus, and that's it, I guess. Let's triple check. From output to one motor lead to other motor lead. I don't think it matters which one goes to which, but let's just do plus to plus and minus to minus, because you can't go wrong. Positive is up. Okay, they're both stuck in. Adequately, I hope. Put everything in the off state first. Okay, so I also put the thermocouple in, and somewhat. It's almost disassembled. Now I'm just gonna power it to see if it works. Okay, mains power is on. And mains. Okay, something turned on. Says about 18 degrees in the room, which is okay, fair enough. And let's see if the motor runs. Seems to be running. And I think the heater is heating, so I will just turn it off for now and unplug the power supply. Now it's time to try to assemble the case and the hopper, cable manage everything. So this is the best I could do. It's pretty terrible, but there seems to be some extra space here in the back. Yeah, I hope that when you do it, you'll keep cable management in mind before actually soldering everything together. I did a very poor job of that, so this is what I ended up with. I'm just gonna try and put the rest of the case on, which frankly I need to move the thing too much to be able to film anything, so I'll just it just goes on, so we'll see. Oh, I got it to fit. There's a lot of cracking that you hear. when you do this. So just be prepared to flex the case like that. It's not gonna get damaged or anything. Now I have to loosen these screws up a bit in the front to get it all to move and fit in the right way, but seems to have done the trick in the end. So just tighten everything back up. Make sure you don't over tighten things because you are tightening on plastics, which will break if you overdo it. I am, however, just going to tighten the top fan a little. Okay, and I'm gonna need one zip tie here to, or maybe just a cable tie is fine. Just to keep the wires out of the fan. Right, I'll just turn it around and see if it still powers on. And if it does, I'll finish assembling the fan and putting the thermocouple nicely in. Should be a hole. It's in the hole. So let's see if we broke anything when assembling the case. I wouldn't be surprised with the extremely shoddy power management, cable management that I did. So okay, that's in. Mains. Okay, seems reasonable. That's heating up. And does the motor turn? It does! And the fans work? Hey! Right. So that's good. Now just to make it nice, I guess. So this should just get one fan, which has to blow upwards, and it just gets zip tied to the thing. So I'll just do that real quick. So I think now it's time to try and get everything nice. Got some zip ties here to try and catch the fan to the insulation. And I think I'll also try and get the thermocouple through. I think I'm just gonna use a little tape to hold it steady. Okay. Just so it stops moving all over the place. Right, so here it is. Here's the front. The fan seems to work fine. Thermocouple measures the temperature. I found another zip tie in the bag, but I had already put this one in, so just gonna leave it like this. I caught the excess thermocouple cable with zip ties here. This just goes in with screws, so I didn't think there's a point in adding that to the video. I'm missing a screw. I might have lost it, or maybe it wasn't included. And of course the hopper, you can put in a plastic bottle. I'm still missing this part of the case because I think I had to Dremel it to get it to fit, and I don't mind if it's open, so just took a shortcut. The button seems to stay in okay, PID controller is mounted okay, so pretty much this is the complete assembly. So we'll see if it actually extrudes plastic or not.